So good morning to all of you. So today we are going to discuss a hydrostatic force concept problem. So a plate is there. This is the free surface of the liquid. This is the free surface of the liquid, and this is my gate. This is the gate. On the side of the gate, the oil is there. On the side of the gate, today we are going to discuss hydrostatic force. On the side of the gate, the oil is there, and the length of the gate is L, and the width it has been kept at an inclination of the theta. Okay, this is the theta, the inclination of the gate, and the width of the gate is B. The density of the oil is given you 850 kg per meter cube. Length of the plate is given you as 240. Okay, and the width of the gate is given as this is 0.75 meter, and so we need to find out what is the hydrostatic force component and center of pressure. So now this is the 3D diagram. This is the gate, and on this side of the gate the oil is there, and it is kept an inclination of how much? Theta. Theta is the 60 degree. Okay, theta is the 60 degree. So we need to find out what is the hydrostatic force component. If it is the exerting the oil hydrostatic force, okay, what is the magnitude of this force and where it will act, at what particular distance from the free surface where it will act. We need to find out this one. Okay, so now we need to understand this one. Suppose this is the free surface of the oil. This is on the free surface of the oil, and this is my gate. This is the side view. This is the gate. The length of the gate is L, and the width is B, and it is kept in inclination of theta. So the oil exerting a hydrostatic pressure onto the plate. So the hydrostatic pressure distribution will be like this. Okay, so this is the hydrostatic pressure distribution on the plate. Okay, now if you find out the resultant of the hydrostatic force, that will be this one. This one, the resultant of the hydrostatic pressure force, and this is FH. Okay, this is FH. Okay, so we need to find out what is this magnitude, and this point where the resultant hydrostatic force will act, this is called as center of pressure. So we need to find out this YCP. What is this YCP? Okay, so if you find out the hydrostatic pressure of the oil, that is nothing but density of the oil into this is G, into this is YC, and this one is A. A is what? The area of the plate which exposed to the oil surface, which exposed to the liquid oil, that area you have to take, means the area of contact of the plate and oil. So density of the oil, what is this YC? So YC, suppose this one is my centroid of the plate, this one is centroid or center of gravity. What is the distance? This distance, this is one is L by 2. This is L by 2, and this is theta. So this one is called as my YC. So this is my YC. So we need to find this one. So because this one is YC, and this is my how much? This is L by 2, and this is theta, and this one is my YC. So YC is how much? This is L by 2 into sine theta. This YC will be equal to L by 2 into sine theta. Okay, so now hydrostatic force magnitude will be equal to the density of the oil is how much? 850 kg per meter cube, and this G is 9.81, and this is L by 2. L is how much given to us? The L is given us, this is 2.4 meter, and the width of the plate, that is 0.75 meter, is given to us, and the inclination of this one is given us as 60 degree. So this is L by 2, this is 2.4 by 2, so into this is sine 60 degree. Okay, and this is area of the plate. Area is how much? This area, if you go, this is the projected area. This is L into B. This is exposed to 1. This is L into B. Okay, so this one is L into B. L is 2.4 into this is 0.75. If you want to find out into this kilonewton, divided by this one is 1000. Okay, so what is this magnitude is coming out? This hydrostatic force exerted by this oil onto this plate, that is coming out to be how much? This is coming out to be 15.59 kilonewton. This is the hydrostatic force exerted by oil onto this gate. This is the resultant force by the oil onto this gate. Where it will act, we have to try to find out the center of pressure. This we have to find out. Okay, so this one, center of pressure is what? Center of pressure, this CP is nothing but this one, this centroid of the, remember, centroid of the, this one is pressure distribution curve. This one is centroid of the pressure distribution curve. Okay, so here the centroid of the pressure distribution curve is one, this one. This one is how much? This is hydrostatic pressure distribution is triangular in nature. So the centroid will be at the distance of 2L by 3 from this free surface, 2L by 3. But we need to find out the center of pressure from the free surface. Center of pressure is measured from the free surface in perpendicular direction. This one you have to find out. And this inclined distance we know 2L by 3. If theta is given to us, how can you find out? This one is the free surface and this point is called center of pressure. And this length we know. What is this length? This is 2L by 3. But we need to find out this one, YCP. And this angle is given us as theta. Just use the triangle rule. So sine theta is how much? This is will be equal to P by H, 2L by 3. Okay, this distance. Okay, so this YCP is how much? This YCP is coming out to be, this is 2L by 3 into this sine theta. So this is 2 by 3 into L is how much? This is 2.4. Length of the gate is 2.4. And this one sine 60 degree. So it will find out that is coming out to be 1.39 meter. Okay, so this is the hydrostatic force magnitude. This is the hydrostatic force magnitude. It is coming out to be 15.59 kilonewton, and which is at the distance of this YCP will be equal to 1.39 meter. Okay, so I think I understood the concept. If some similar question it will come in your exam, GATE, ASC or any university exam, I can assume that you can able to solve the question. Okay, so thank you friend. The earlier, due to bad internet connection, the buffering issue, the OS and the voice and this visualization is, there is no problem in synchronization. So that's why I created a link for you, and the video will be available later on. So thank you, have a good day.